Hello everybody. Today I will discuss about relays and contactors. Use of these relays and contactors in electrical drives. Basically, these devices are used to allow current across the circuits. We will use these devices for starting different types of motors. That means starting of DC motors, starting of AC motors. We will discuss in brief about the starting methods of these motors. Most of the portion already you have gone through in electrical machines and some portions in electrical drives. Relays and contactors for electrical drive. Basically, these relays and contactors operate on the same working principle. Both are electromagnetically operated devices controlled by a magnetic coil. A magnetic coil is there which is to be energized from the same supply or isolated supply. When the magnetic coil gets energized, it will attract the metallic plate, or you can say the plunger, and that plunger connects the two terminals of the wire to give path to the current. The difference between these relays and contactors is that relays are generally used for low power applications, low voltage, low current applications, but contactors are used for high power and high voltage applications. So we can say in single phase system, relays are more suitable, contactors are suitable for three phase systems. 5 to 20 amperes relays are available in the market, whereas contactors range is from 9 to 12,000 amperes. One thing is to be kept in mind that contactors are not used for any protection, or you can say overload or short circuit protection. These are just used to give path to the current. When it is closed, current will flow through the circuit. When it is off, it is open, then current will be blocked. So this overload or any other protections is to be solved separately. Now from this discussion, it is clear that these relays and contactors are providing path to the current. Same thing is possible with the help of power electronic switches. We have discussed for high power applications, thyristors are there. When the thyristors are triggered or firing pulses are given, then the thyristor will be on and it will allow current across the circuit. For AC motors, bidirectional switches we can use as these relays and contactors. For DC motors, unidirectional switches will be used. Bidirectional switches can also be developed using unidirectional switches. So nowadays we can say that these relays and contactors are being replaced by these power electronics switches. Reason behind it is that the switches are very fast, available in wide range from low power to high power applications. High power thyristor, low power transistor or MOSFET, medium power you can use IGBT. Other advantage is that the switches are highly reliable, highly efficient, cost is very low and can be controlled easily by providing suitable pulses across the base or gates of the circuits. Now suppose if we want to make our drive system or starting system automatic, in that case it must be self-operated. That means it will sense some parameters across the circuit. It may be voltage, current, torque, speed, etc. Based on that, it will generate switching pulses if it is semiconductor based relays and contactors, or it will generate current to energize the magnetic coil in case of electromagnetic relays and contactors. So automatically it will keep tracking the parameters, voltage, current, torque, speed, and will generate the switching pulses of the magnetizing current to magnetize the magnetic coil. Then the system becomes automatic, but complexity of the system increases. So I will consider simple circuits here to discuss for the time being. Starters of AC motors. Let us discuss about this starter, direct online starter in brief. It is the most fundamental, economical as well as easy method for running a three-phase induction motor. Contactors are used to connect three-phase supply with three-phase stator windings. You can see fuse, thermal overload relay. These are used for short circuit as well as overload protection. So these are separate issues or separate problems to solve. But contactors here are used just to provide path from three-phase supply to the three-phase stator side. You can see 4 vertical boxes are there, and those represents contactors, and a horizontal line is there that you can say it is plunger, and it is connected across the magnetizing coil. Now whenever the magnetizing coil is energized, it will draw that plunger towards right hand side. Then the contactors will close the path between three-phase supply and the stator, and current will start flowing from source to stator winding and the motor will start. Now to start this one, initially normally open position is nothing but a push button. So this button we have to push, then the magnetizing coil will energized, then the push button will come back to its initial position, still magnetizing coil remain energized. Reason behind it is that now the magnetizing coil is getting path from the stator supply. You can see right most contactor will give path to the magnetizing coil through stator. The main disadvantage of this method is that initially it will draw more amount of current. So this method is not preferred for high power rating induction motors. Star delta starter. Here the problem of direct online starter is reduced up to some extent. We know that if we can reduce the supply voltage, then the current will reduce. So that technique is used here. Initially the motor is started with star connections, because in star connection we know that VL is equal to root 3 VPH. So the phase voltage is VL by root 3. In case of delta connection, VL is equal to VPH, or line voltage equal to phase voltage. So if the motor is started with a star connection, then the phase voltage is reduced by 1 by root 3 times. Subsequently, torque will be reduced by 1 by 3 times, because torque is directly proportional to voltage square. So initially the motor will be started with a star connection, then at running condition it will be switched to delta supply, and this is done with the help of connectors. So as I've discussed earlier also, the function of connector is to just give a path, and the connectors can be replaced by power electronics switches also. This type of starter is very much popular for high power rating induction motors. Other methods of starting AC motors are auto transformer starter, static rotor resistance control methods. In auto transformer starter, basically the purpose is to reduce the starting current by reducing the starting voltage by changing the taps of the transformer. So different tappings, 50%, 60%, 85% tappings are there to reduce the starting current. So it is just like star delta starter to reduce the starting inrush current with comparatively more flexibility. Static rotor resistance control we have discussed already in speed control of 3-phase induction motor. So you can see that lecture class. This is suitable for slip ring induction motor. Basically, rotor resistance is kept high to develop high starting torque. Once the motor starts, then these resistances or the external resistances across the rotor is reduced. Now let's discuss in brief about starting of DC motors. Let's take a case of DC shunt motor. Here at the time of starting there is no EMF or opposing force developed to oppose the current. So as the resistance of armature is very low, so high starting current can flow through the armature windings and can damage the windings. So initially resistance is kept in series with the armature so that current is not increased too much. Slowly the resistance is reduced as the speed of the motor increases. So this is the basic of starting a DC motor. Now we will see how connectors are useful in starting these DC motors. Let's take an example of automatic starter for DC shunt motor. Here initially the armature current is controlled by energizing the contactors. So there are 4 connectors used in these circuits: M, 1A, 2A and 2A just above the rheostat. At the time of starting, connector M and connector 2A just above the rheostat is energized. Then current will take the path L1, M, R1, R2, overload sensor A1, A2 back to L2. At the same time, current will be there in the field winding in the direction L1, M, 2A, F1, F2 and L2. Now, this connector 2A just above the rheostat is to be energized because at the time of starting, flux strength must be more so that starting torque will be developed. Once the motor is achieved rated speed, then the field winding resistances can be placed across the system. To control the armature current or to reduce the inrush current, 1A and 2A are not energized. As soon as the speed of the motor increases, slowly the connector 1A and connector 2A is energized. So at the time of starting, connector M and 2A just above the rheostat is closed. 1A and 2A remains open. Number of connectors can be used to increase the number of resistances R1, R2, R3. Now to make this system completely automatic, as I discussed earlier, that the energizing coil will get pulses or currents from some sensed value. So It may be based on the speed of the motor or current flowing through the armature or EMF developed across the armature. It will be sensed and decided that motor is running at rated speed or below the rated speed. As soon as the rated speed is achieved, all the connectors will be energized to allow full current across the armature. In this way, we can make our starter automatic. Today we have discussed about difference between relays and contactors and how these contactors can be used to control the speed or start the motors. In brief, about different starting methods of AC motors and one automatic starter we have discussed. Thank you and be safe.